All right, I'm going solo on this lesson. This one is on graphing ratio tables. This time, instead of getting a notes page set up, you're going to need your textbook. We're going to actually do some problems right out of the textbook. That way you don't have to draw out your graphs and all that kind of stuff. So you don't need to jot this stuff down. We just need out our textbooks, and we're going to be working right out of there today. So if you would, flip in your textbook to page 50, and we're going to do the guided practice problems down here. So it's about halfway down the page, and we're going to get started on this first one together. So it says, two friends are each saving money in their bank accounts. Sorry, that's a really bad line. Marcus saves $10 each week, while David saves $15 each week. We want to make a table that shows how much they've saved each of the first 4 weeks, and then we're going to plot that information for problem 2 in our actual graph here. So we're going to start with Marcus. It says Marcus saves $10 each week. So for week 1, he saved $10. Week 2, he already saved $10. He saved 10 more, so now he's up to 20. Week 3, he's up another 10, and week 4, he's up another 10. So it's just growing by 10 each week. The number of weeks is our x-coordinate. Our y-coordinate is the amount that he saved. So now we're going to write it as a coordinate pair. Remember, it's an x and a y that we plot as points. So this one would be 1, 10. Then 2, 20. That 0 was a little nicer than this first one up here. 3, 30. And 4, 40. So we just took our x and our y and turned them into coordinates for us. Now let's do the same thing with David. David saves $15 each week. So week 1, he saved $15. Week 2, he saved another $15, so he's up to $30. Week 3, he's up to $45, and week 4, he's up to a total of $60. Again, write your x and your y as coordinates. So we have the point 1, 15, 2, 30, 3, 45, and 4, 60. Okay? So we've simply plotted all of our information, all of our ratios of the weeks to the dollars saved in our ratio table. Now we want to go ahead and graph those ordered pairs. So this would be a good one if you did each person in a different color, or maybe did one light and one dark, so we can kind of tell the difference, because we're going to have 2 sets of data on the same graph over here. So for Marcus, we have a 1 and 10. So first number means we go over to 1, up to 10 and place our point. Second data value is 2 and 20. So we go over to 2, up to 20. Then we go over to 3 and up to 30, over to 4, up to 40. And I know on your copy you can actually see the grid lines. Mine are kind of a little too light to see here. You'll notice that they kind of go up at a nice, steady pace. It makes a nice straight line for us. So that is Marcus. Now we want to do the same thing with David. His first point is 1, 15. So I go over to 1, up to 15. So do a little estimating. It's halfway between 10 and 20. 2 and 30. So now I go 2 and 30. Then we go up to 3 and 45 and 4 and 60. But again, you'll notice it kind of follows a nice straight line. This is David. So we could continue those lines up and continue to gather more information if we wanted to. We'll know it follows that pattern. But question 3 is where you earn your money. How do the ratio of Marcus's savings and David's savings compare? And how is it shown in the graph? Please do not give me something so boring as David's is higher. Of course David's is higher. We can see that. We want more information. So if your little first or second grade brother or sister could answer a question that way, we probably want more from a 6th grader. So don't just tell me it's going up. What do you notice about the graph? Yes, David's is higher. But do you notice how they started out really close and then got a little farther away and a little farther away? Notice how David's is getting farther and farther. If we were to go way up here, David would be over here and Marcus would be somewhere like over here. It's a huge difference. So a good comparison would be that as the weeks go on, David's is growing faster than Marcus's. It's getting higher. Or the difference between the amount that Marcus saved and the amount that David saved is getting wider and wider and wider as the weeks go on. So don't just tell us it goes up or who's on the higher one. Give us some more information. Give us some details about how it's changing. Oh, how did that one sneak in there? Hopefully you're all Cub fans. Hopefully you're happy the Cubs are doing so well in the playoffs. If you're not Cubs fans, well, I snuck it in on you anyway. So now flip to the next page, page 51. So we're going to go ahead and do a similar problem. This time, we already plotted all the data, or we already gave you all the data. It's just our job to go ahead and put it in our graph. So we're just going to plot each of our ordered pairs and then see what we can find from the information. So we start with 0, 0. That's down here. Then 1, 4. So 4 is a little bit below the 5. 2 and 8. So go up to the 8 there. 3 and 12. So 3 is just a little bit in between the 10 and the 15. But again, as we'll see in most of our data, it kind of goes up at a nice even rate. It kind of follows a nice straight line. Question 2, this is where you earn your money. Describe the pattern. If your first instinct was to go, it goes up, that's not describing it. That's nothing useful to us. How is it going up? Is it going up slowly? Is it going up at the same amount or a different amount each time? Is it a sharp, steep curve or steep line or a very shallow line? So in this one, a good description would be it's increasing by 4 minutes each time. Or it's increasing at a steady rate of 4 minutes or 4 pages per minute. I'm sorry, 4 minutes per page. I had it backwards there. Give us some specifics about the number, not just a general description, it's going up. Okay? All right, so drop down to problem 3, 4, and 5. This one's similar to our warm-up one. So if you think you know how to handle this one, feel free to do it on your own. If not, let's tackle this one together. It said, Ken's Home Supply charges $5 for each foot of fencing. So we're going to come down here in our table. So it's $5 for each foot. So 1 foot is $5 for the fencing. 2 feet would be $10, $5 per foot. 3 feet would be $15, and 4 feet would be $20. So we write them as coordinates here. The number of feet and the cost for the fencing. And then I'm going to plot them in my graph. So 1 and 5, 2 and 10, 3 and 15, 4 and 20. So that is for Ken's. Now do the same thing for Wayne's warehouse. He charges $6 for each foot of fencing. So we already know he's going to be more expensive. So that first foot is $6. The second foot is $12. 3 feet, so 3 times 6 is $18. And 4 would be $24. So we have 1 and 6. Remember, X always goes first. 2 and 12. 3 and 18, and 4 and 24. So we plot those points. So 1 and 6, 2 and 12, 3 and 18, and 4 and 24. So this one's a little harder to tell from the last one, but do you notice how they started really close and got a little farther and a little farther, and they're starting to grow farther and farther apart from each other? That's the kind of thing that we want to notice. So Wayne's is increasing, but it's increasing at a faster rate. Of course, the price is increasing for each one of them, but how fast is it increasing? Wayne's is going up by an extra $1 each time. So while they were only $1 apart to start, 5 and 6, by 4 feet of fencing, they're $4 apart. Imagine if you had a huge backyard and you had to go the whole length of your backyard. 1 foot for every single foot of fencing, that adds up pretty quick in terms of a difference in price. So comparing this here, something that we compare is that while both prices are increasing, Wayne's is increasing at a faster rate. It's going up by an extra $1 each foot. So the more feet of fencing that you have to buy, the larger and larger the distance you're going to find between the two of their pricing. All right, we are all done for today. We will do a little practice with this tomorrow in class.